Today we will continue talking about set theory. We will investigate Venn diagrams and learn about set operations. Before we begin with our operations, let's just kind of think about what an operation is. It's an action. So if we're looking at an operation of sets, we are looking at things that we can do with them. The first operation we can do is we can take two collections and we can combine them. The mathematical term for this operation is a union. A union is denoted by a little u, and so we say that A union B is the set X, so that X is in A or X is in B. The next operation is called the intersection. And so if we have two sets, it would be a natural thing to say what do they have in common, and that's the idea of an intersection. The intersection is denoted by an upside down U, and so we say that A intersect B is the set of all elements X, so that X is in A and in B. If we have a set, we could talk about what's not in that set. So again, that's another operation. This is the idea of a complement of a set. The complement symbol is a little tick mark, and so we say that A complement is all elements X, so that X is not in A. This is the first example where we need to know the universal set. In other words, what is the set of all elements? We'll discuss that in more detail later. We can have the difference of A and B, which, just like in math, the difference is subtraction, so we use a subtraction symbol. And we say that A minus B is the set consisting of all X, so that X is in A, but X is not in B. Lastly, we have the Cartesian product. The Cartesian product is ordered pairs. So you can think maybe about like the XY axis and points. So you have something from the x-axis and something from the y-axis, except now in terms of axes, what we have are sets. So the product of A and B consists of ordered pairs, x comma y, so that x is in A and y is in B. All right, now that we have those definitions, let's actually use these with real sets. All right, so here are two sets. We have A and B, and our universal set is the set of all elements at all numbers 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is our universal set. We're going to assume that no other numbers exist, and we'll see why in a minute. All right, the union of A and B, well again, union means combine, so we want to take all of the elements in A, so we have 1, 2, 3, and 4, and then we also want to throw in all of the elements in B, so we have 2, 4, 6, 8, and 10. You'll notice that we could write 2 twice because 2 is in A and 2 is in B, however that's redundant in terms of sets. We have A intersect B, so when we're looking at the intersection, we want to know what they have in common, and the only elements that they have in common are 2 and 4, so therefore A intersect B is the set consisting of 2 and 4. Now that we have done two operations, let's look at the complement. And this is where it really matters that our universe only consists of 10 numbers. If I wanted to talk about every number outside of A, you might say, well, that's, maybe -5 is in the complement. But because we're restricting our universe to consist of only the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, when I say A complement, that tells me I'm looking for all of the numbers in the universe that's not in A. So I take all the numbers 1 through 10, and I don't want to consider 1, 2, 3, and 4. So A complement consists of the numbers 5, 6, 7, 8, 9, and 10. B complement, again, this set consists of all of the elements not in B, and so we take all the numbers that we see, which is our universe, and we want to only consider the ones not in the set B. So for instance, B complement consists of the elements 1, 3, 5, 7, and 9. We can look at A minus B. So again, this is the set where you take all the elements in A and you throw out the ones that are in B. So since we have A, we have elements 1, 2, 3, and 4, but we want to throw out the elements that appear in B, and so we throw out 2 and 4. It's important to realize that A minus B is not the same set as B minus A. If we follow the definition with B minus A, this consists of all of the elements in B that are not in A. So we look at this and say, okay, well, 2 is in B, but since 2 is in A, it's not in the difference. 4 is in B, but it's in A, so I don't want to consider that. 6 is in B, it's not in A, so that's okay, as well as 8 and 10. If we look at the Cartesian product, again, these are ordered pairs. A cross B consists of pairs where the first element is in A and the second element is in B. So if I list all the ways to pair these guys up, I would have the pair 1, 2, the pair 1, 4, the pair 2, 2, the pair 2, 4, the pair 3, 4, and the pair 3, 2. And I can also look at B cross A. So now this tells me that the first number or the first element in the pair has to come from B, and then the second element needs to come from A. So I would have, for instance, the pair 2, 1, the pair 2, 2, the pair 2, 3, and the pair 4, 1, 4, 2, and 4, 3. If you look at these sets, these are definitely different. For instance, one of the elements in the set A cross B is 1, 2, but the pair 1, 2 is not an element of B cross A, so therefore these are definitely different. Alright, now let's look at these Venn diagrams. A Venn diagram is simply a way to draw a set. If we have two sets, we generally just use circles to denote the sets. We have a box to denote the universe. A union B on the far upper left is the union, or when we combine everything in both sets. On the upper right-hand side, we have the intersection. So the intersection is what they have in common, and if we look at the circles, we can see that the circles overlap in that little sliver, or the little eyelet. A complement is everything outside of A, and so we color in what is represented by this operation. And then we also have A minus B on the lower right, and this is everything in A that's not in B. So we don't color in the little eyelet for A minus B because we don't want to consider things in B. Alright, that concludes the lecture for today. I hope you feel, after doing the exercises and reading the notes, that you are comfortable with these operations. And next time we will work on Venn diagrams and operations in more detail.